Hi everyone, welcome to this tutorial on physical chemistry. So we're going to discuss quantum mechanics. Before the advent of the 19th century, scientists were puzzled on how to arrange electrons around the nucleus of an atom. That was a big question, a big problem. In 1900, a scientist known as Max Planck gave us the idea of energy quantization. He said that that the energy levels or shells in an atom are quantized. And that name for energy level is shells. Meaning that each shell has a discrete amount of energy. After Max Planck, 5 years later, a man called Albert Einstein did similar work like that of Planck. However, Einstein did not say that energy levels are quantized. He said that apart from energy, that radiation is also quantized. Einstein introduced the word called photons in physical science. Photons mean discrete amount of radiation. Then, looking at Einstein's work, Planck developed an equation known as the Planck equation, given as E equal to hf, where E stands for the energy of a photon, h is the Planck constant, and f is the frequency of radiation. The Planck constant h is 6.626 times 10 to the power minus 34 joule seconds. So this is the Planck constant. So you want to calculate the energy of radiation or energy of a photon, we apply the Planck equation. And we know in physical science that velocity of wave begin by lambda, otherwise known as wavelength, times frequency. The velocity of light is constant. So in physical science, we use c to present the velocity of light instead of using v. So v and c are equivalent here, equal to lambda times frequency, making frequency the subject. Frequency now becomes c all over wavelength. So from this formula, E equal to hf, we can as well say E is equal to hc over lambda, substituting f with c over wavelength. So these two equations, formulas are the same, known as the Planck equation. Then, how do we apply the Planck equation? Let's have a question that says, calculate the energy of a photon of frequency 100 Hz. The Planck constant given as 6.6 power minus 34 joule second. So let's say we have this kind of problem to tackle. So we have frequency as 100 Hz. So we have to, let me use the word kilohertz, 100 kilohertz. So kilohertz is not a standard unit of frequency. Frequency is in hertz. We convert to hertz by multiplying by 1000, because 1 kilohertz is equal to 1000 hertz. So that gives you 10 to the power 5 hertz. So applying E equal to hf, we now use h is 6.6 power minus 34 times frequency is 10 to the power 5. So when we solve this, we now have E 6.6 power minus 34, applying the law of indices on these two exponents, adding them together. We now have 6.6 times 10 power minus 29 joules as the energy of the photon. So the working is clear. You can as well apply this formula to find the energy of photons if we are given the wavelength of light and the velocity of light. The velocity of light is constant, which is 3 times 10 to the power 8 meter per second. So having understood Planck concept and also Einstein that introduced the photon, we now move to another man that worked or that contributed on quantum mechanics. The person is de Broglie. De Broglie gave us the wave particle duality of matter. So according to de Broglie, matter can behave as a wave as well as a particle. So what are the wave characteristics of matter? So they include reflection, refraction, diffraction, interference, and polarization.